Today we're going to talk about probability of multiple events. The first thing we're going to talk about is the difference between independent and dependent. Dependent events occur when one event affects the second event. Independent is the opposite. One event doesn't affect the other. Let's have some examples where you can pick out independent versus dependent. So let's look here at problem 1. Roll a die, then spin a spinner. There's supposed to be an N there. Is this independent or dependent? Well, I don't think rolling a die has anything to do with spinning a spinner, so I think this is independent. Because these two things do not affect each other at all. Let's take a different example. You choose a flashcard from a stack. Then you choose another from the same stack. Is this independent or dependent? Well, I think the second event depends on the first event because once you take one card, there's one less in the stack than before. So I would say that the second is dependent on the first because there will be fewer cards in the stack. Okay, let's talk about probability if events are independent. So if A and B are some kind of independent events, like rolling a die and spinning a spinner, then the probability of A and B happening is just P of A times P of B. Let's look at problem 2. At a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you get a diet drink and fat-free chips? Phew. Okay. So we're talking about the probability of a diet drink and fat-free chips. Okay. Well, we're going to have to decide if this is independent or dependent. I don't think the drinks have anything to do with the chips, except for that you're picking both. So I think that these are independent events. So if they're independent events, then the probability of D and F would simply be the probability of D times the probability of F. What's the probability that you choose a diet drink? Well, how many drinks are there? Careful. There's 15 altogether, because there's 10 diet and 5 regular. So the probability of choosing a diet drink then would be 10 out of 15. The probability of choosing fat-free chips, there are 8 fat-free and there are 12 regular. So the probability of choosing fat-free chips would be 8 over 20. Because these are independent events, you would simply times these together. You can make that a 2. You could make that a 4. We have 4/15, which is about 0.267 or 26.7%. Okay, let's talk about this new term we have. Oh, I keep missing it. There we go. Mutually exclusive events. Mutually exclusive events are two events that cannot occur at the same time. For example, let's go back to that picnic. Drinks are either regular drinks or diet drinks. You can't be some of both. You're either one or the other. Therefore, those are mutually exclusive events. However, let's say some of the drinks were in cans and some of them were in bottles, and some of them were regular and some of them were diet. Well, a can and a diet drink are not mutually exclusive because you could be a can and a diet drink at the same time. Okay, let's have some examples. You roll a die. Are the events that can happen mutually exclusive? Well, it depends on what the question of rolling the die is all about. How about rolling a 2 and rolling a 3? Can you roll a 2 and a 3 at the same time? Is that possible? No, they're different numbers. They don't have anything in common when they just say rolling a 2 and rolling a 3. Therefore, these are mutually exclusive. They don't have anything to do with each other. They don't affect each other. But let's look at B. Rolling an even number and a multiple of 3. So are those mutually exclusive events? Well, what are the even numbers when you're rolling a die? 2, 4, 6. And what are the multiples of 3 when you're rolling a die? 3 or 6. Do you see how they both have the 6 in common? That means that these are not mutually exclusive events because the 6 appears in both sets. Or could you be an even number and be a multiple of 3 at the same time? Yes, you could. Okay. If A and B are mutually exclusive events, then the probability of A or B happening is the probability of A plus the probability of B. And we sort of already knew that from our last section. You know, you had the marbles, they were all different colors. What's the probability that you pick a green one or a white one? Well, those are mutually exclusive events, and that's why you could just add those probabilities together. If A and B are not mutually exclusive, then you have to account for the overlap. So if we go back up here to B, do you see how being an even number and being a multiple of 3, those both involve the number 6. So if you were to just simply count these up, 1, 2, 3, 4, 5, you would have counted the 6 twice, and you can't count the 6 twice. So you would have to account for that by taking one of those 6s away. So if A and B are not mutually exclusive, then the probability of A or B is P of A plus P of B, but you have to take out the probability of A and B. So let's go back to this rolling an even number. The probability of rolling an even number and a multiple of 3 would be 1, 2, 3, 4, 5 out of 6, but minus 1 out of 6, minus the probability of being an even number and a multiple of 3 at the same time. And the only number that can happen with when you're rolling a die is 6. Okay, let's have another example here. Oh, I'm going to call this the overlap. I said it, but I didn't write it. Or what they have in common. Okay, problem 4. At your high school, a student can take one foreign language each term. About 37% of the students take Spanish, and 15% of the students take French. What is the probability that a student chosen at random is taking Spanish or French? So the first question has to be, are these mutually exclusive? Do they have anything in common? Do they share anything? Well, in some schools, yes. In our school, you can take Spanish and French at the same time. But what does it say up here? It says at your high school, a student can take one foreign language each term. So in this particular case, these are mutually exclusive events because you can't take Spanish and French at the same time. Therefore, the probability of taking Spanish or French is simply the probability of taking Spanish plus the probability of taking French. Spanish was 37%, French was 15%, so that's a total of 52%. So you have a 52% chance of choosing a kid at random and they're taking Spanish or French. Let's look at problem 5. This was my favorite one because I got to draw all these shapes and fill them in. That was exciting. Sometimes it's the little things, you know. Suppose you reach into a dish and select a token at random, so one of these shapes. What is the probability that the token is round or green? So the first thing you need to do is ask yourself if these events are mutually exclusive. Is it possible to be round and green at the same time? Of course it is. Right here and right here. Those are two items that are round and green at the same time. So being round and being green are not mutually exclusive events. However, being green and being a triangle would be mutually exclusive events because there are no green triangles in this dish, whatever, this circle. Okay, so these are not mutually exclusive. Therefore, the probability of being round or green is the probability of being round plus the probability of being green minus the probability of being round and green. So how many items are in the dish? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's my total number of outcomes, possible outcomes. So the bottom of all of these fractions is going to be 9. What's the probability of being round? Well, that's 1, 2, 3, 4, 5. So the probability of being round is 5/9. That's not going to work. What's the probability of being green? 1, 2, 3. So 3 out of 9. And what's the probability of being round and green? Oh, I chose the one color I already used. 2 out of 9. So now you can combine this to get the true probability of being round or green. And that will be 6/9, which is equal to 2/3. I liked this example, so I added in some extra questions. What is the probability that the token is square or red? Well, can you be a square and be red at the same time? Yes, he's right here. So that means that these are not mutually exclusive. So the probability of being square or red is the probability of being square plus the probability of being red minus the probability of being square and red. What's the probability of being square? 3/9. What's the probability of being red? 2/9. And what's the probability of being a red square? 1/9. And that gives us 4/9 altogether. Okay, last one. What is the probability that the token is green or square? So the probability of being green or square is the probability of being green plus the probability of being square minus the probability of being green square. So green, there's 3. So that's 3 out of 9. Squares, also 3 out of 9. And green squares, 1 out of 9. So there can be a lot more to it than that. You can take whole courses on probability in college, and they get pretty detailed. But this is just Algebra 2, so that's about as tough as it's going to get for now, I think. So please try the homework problems, and don't forget to submit your notes and submit your homework for credit.